Hi there, and welcome back to my TechIt world. And as you can see behind me, this computer is doing something different. This has taken quite a while to create, and it looks fairly simple. So we now have Turtle 1, Turtle 2 and Turtle 3 showing what looks like location info but question marks, and this counter which is going round. We also have 3 turtles over here sat doing nothing. Now if we go into those so that they boot up, what you will find is that they begin to report back their location info to this computer. So each loop round in the poll, it will check one of those turtles and ask it to say, where are you? And if it responds, it will update it on this display. And the idea is that if the turtles are off and running elsewhere in another area of the base or off on a mission, as it were, then if they get lost, I'd have some way to refer back to where did they get to track them down. Now, how does this work? Well, the first thing is that the turtles have a wireless modem attached. You can see the red line round it, which shows that it's active. Now what that allows it to do is it allows it to talk to other computers wirelessly using a set of protocols. And what somebody had done is they've created a GPS protocol, because one of the messages you get back when you talk to another computer over this is the distance between you and the remote computer. So what there is on the roof of this world, I shall fly up and out this way because it's probably the quickest way out. I've created a GPS array of computers to respond to requests for location info in the area. So each one of these computers is running with a wireless modem on them, serving out requests saying, where are you? And it will respond. So there's a program that's built in to the computers called GPS. And if you do GPS host and give it the location info, in this case I've specified the location of each of these 4 devices in real world coordinates. So if I bring up F3, you'll see that those coordinates, bring it round here so they're on the screen at the same time. So we've got -17 is where I am, so -15 is where the computer is. 295 is Z in Minecraft terms, which corresponds to 296 in X in the GPS terms. Minecraft oddly has Y as the vertical axis and Z as the second horizontal axis. And 103 is the height, which is 104 in Minecraft terms there, because I'm slightly higher than the computer. So having programmed that in to all 4 of these, they will then respond to any request from another terminal in the near vicinity. It doesn't work too far away. There is a limit in Computercraft of X number of blocks, otherwise it won't allow the computers to talk to each other. But it will return a distance, and then it uses triangulation in the code to work out how the X, Y and Z coordinates for each of these turtles. So each of the turtles is running a program which checks its location using the GPS, and then has a loop waiting for poll commands from this computer to ask it to tell it where it is in the world. So if we have a look at one of these computers, if I terminate that program and if I edit the startup program, so first of all I've added a version at the top. That's just so that I can track which version's running, so that all 3 turtles are running the same version. There's then this open function which is copied from the GPS program that's within the ROM for the Computercraft things. This just because it already includes the code to search around and find which side of the computer has a wireless modem attached and open it ready for use. So that's the code to do that. It then finds out what the name of the computer is. Now I'll just explain that. In here, if we do label get, I've labelled each of the turtles with a name: Turtle 3, Turtle 2 and Turtle 1. And what the code does is it checks the last letter of the label. So first of all, it gets the label using the Oz API get computer label method, and then if the label exists in the Lua command, an if with something will return true if the thing exists at all, then it sets the NMyID to the last digit of the label. So that works by taking the subpart of the label, so the string.sub, so calls the string API with the sub method, passing in the label string and then starting position of string len value returning the length of the label, and the end position is the same. So it literally gets one character from the end of the label and uses that to set it to my ID, and it converts that string to a number to do that. It then has a local X, Y and Z variable which it will be used to keep track of anything else the turtle's doing in terms of its code and to update its position. And the idea was, as the notes here say, it would only periodically then check the GPS after initially locating itself to update it as it goes. So first of all, it does an if open, which calls the function at the top, and if it returns true to say it managed to open the wireless modem, then it enters this loop. If it doesn't, then the code just exits at the bottom. It then keeps track of how many times it's responded to a location request, the nServed variable. It then has a flag here for a remote abort command. So the idea being here, if it was running a long program mining and then the main computer told it to abort, you'd be able to send a signal to break out of the loop for that. I've not actually responded to those signals yet, but the code's in there in the loop. Clears the screen, sets the cursor position to the top left, writes out the turtle remote control version and the version variable from the top of the program. I hate the way this works. Right. Then if the label exists, it then says that it knows what it's called, so I am label, and it writes that out to the screen. Otherwise, this would come up to tell you that it's not named, and that would therefore mean it can't respond to any remote requests. It then populates the X, Y and Z variables using the GPS API locate method with a timeout of 2 and false, meaning don't print any of the debug information. It then prints out the position it's returned from that onto the screen so that you can see that. It prints a gap and then prints a command just waiting remote orders. Then if it's sent any GPS information previously, it will then write out the fact of how many of those it's written to the screen. It then moves the cursor back to where it was before. Then it waits for a response. So the sender message and distance get populated by calling the RedNet API with a receive command. And what that does is it returns a value for the sender ID of the computer that sent the message, which is a text, and vitally the distance information. If you're actually using this for GPS calculations, I'm not using that in this part of the code. And if the message is where turtle, which is the text of the message I've used to get the two systems to talk to each other, the main computer and the turtles, followed by the relevant ID for this particular turtle, then it will respond with a message back to the sender. So again, it calls the RedNet API with the send method to the sender, so back to the computer that asked for its location, saying turtle report is the message it sends back, and it concatenates to that using the text utils API a serialized version of this turtle's ID followed by its X, Y, and Z coordinates. And what that does is it takes those numbers and it converts them into a string of the form like so, where that would be the X value, and then the second parameter being the Y value, etc., for the up to the Z. And so that's the text serialize thing command method. It then updates how many times it's responded to that. And then that's it. It ends all the loops and it keeps going around that loop, waiting for a thing, asking it to say, where are you? And responding, saying where it is. So that program is relatively straightforward. And I'll just start that again. And then this program is slightly more complicated. So in here, don't terminate it that way, terminate it with there, otherwise it messes up. Edit. I'll edit that version, it's slightly shorter the type than the startup one. So this has the similar open function to automatically find where the wireless modem is attached and open it up to use. It has a function to print out where a particular turtle's location info is. Now, to explain that one, I need to go down here first. The location info for the turtle is stored in a table, and the table is of this form in Lua. So the elements in a table are each surrounded by curly braces. So that is an empty table with nothing in it. That is a table with a single number in it. That would be a table with a string in it. And a table can have multiple values within it of different types, etc. So that would be a table with 3 elements in it, a string, a number, and a string. And a table can contain other tables. So it could be a number, followed by a table, followed by another number. So that would be a table with 3 elements in it, where the second element is itself a table with 3 elements in it. So what I've done is establish the location info as a table made up of tuplets. So each entry has 3 strings in it for the different X, Y, and Z location info for that particular turtle. So element 1 in the table corresponds to the X, Y, and Z values for turtle 1, etc., turtle 2, and turtle 3. And then those are used here when printing the location info out. So this function, you pass in which turtle you want to print things to the screen. It gets the X, Y, and Z from the nTurtle location table with the index of whichever turtle it is that you want to print. And the X is item 1 in the tuplet, Y is item 2, Z is item 3. It then converts those to strings suitable for printing in a nice concatenated form, and then prints out turtle, and then the turtle number, followed by its X value, its Y value, and its Z value. Okay. The update function is similar, where you pass it in a table in this case as to what you want to update. So the table will also contain the ID of which turtle needs updating. So it has local variables for the turtle ID, the X, Y, and Z that need updating for it. It gets the turtle ID from the first item in the table that's passed in. It gets the X value from the second, the Y value from the third, and the Z value from the fourth. It then prints out that that turtle is the one that responded, and then updates the turtle location table for that turtle with the relevant values X, Y, and Z. Okay, so the first thing it does is it sets a value for the modem and tells it to open it. It keeps the same C flag, which is the one I'd used way back when for the abort lever to tell the program to quit. Initializes the table, opens the monitor up for writing to. All of this is the same as the program was before this part. Clears the terminal, moves to the top left, prints running the monitoring program on the main computer screen, and then redirects all the terminal output to the monitor, the big version. It then sets the scale to 1, and that can be changed to 2 if you need 2 to make it bigger. It then has some more local variables, including the update frequency, how often to poll the turtles, and which value to start from. So poll frequency is how often it will update, and poll count is which state in the countdown is it at. I've used a countdown because it was easier to change the numbers that way while I was writing it. And similarly, the polling works in a countdown value. So n to poll is which one it needs to be polled next, and n number of turtles is the total number of turtles to poll. So while C is fault, so while you haven't got the abort lever down, clear the monitor, set the cursor to the top left, print the world time, and put the timeout on the screen. Run the red probe command. Again, this is the same as the program was before to show the status of the red probe, red bundled cables, and then it prints the turtle location info for turtle 1, turtle 2, and turtle 3. That could be a for next loop. Ideally, if you got more turtles, I would expand it that way. It just wasn't worth it for 3. And then it counts down the poll and shows what state it's at with the poll. If the polls reach 0, then it resets the poll to the poll frequency and says that it's going to do a poll. It then uses the RedNet API with the broadcast method to send the message where turtle. So that will go to all computers within range, with where turtle as the string added to it the string for the turtle it particularly wants to poll this time round. The true on the end, I forget what it's for. Good question. Can't remember why the true was needed on the end, what that meant. It needs to be true, whatever it is. I'll come back to that if I can remember later. N poll then gets decremented, so which turtle to poll next gets decremented, and if that's gone below 1, then it resets it to the number of turtles. That could equally be if it equals 0. It then waits for responses, so it uses the sender. It sets the sender message and distance to the value it receives back from the RedNet API, waiting for up to 0.2 of a second for a response. Now, one of the complications that I found in writing this was because there are 3 terminals, when each of these gets the response, gets a request for its location info, it will recheck its GPS coordinates in the loop. And in order to do that, it sends out a ping message to all the computers in range, asking them to respond to work out where it is geographically. Now, the problem was that if I assumed that because I've asked for a message from a turtle, that the message I'll get back is its response to that, then often these ping messages got in the way, and I was missing the message that was saying it was actually responding with the details. So what I added in was a loop here to say if the message that you got back was ping, keep going in a loop, getting the next message, waiting up to 0.2 of a second. Now obviously if it doesn't get a response, it's only going to wait another 0.2 of a second anyway. Then it sets the message to what the message is, or if it was null, it sets the message string to be an empty string. And then if the subpart of the message for the starting at character 1 and the first 12 characters is turtle report, so it's one of the turtles is responding back, then it gets the location info to update from unserializing using the textutils API. There's an unserialize command which takes the opposite of the one I showed you before. So where it's created a string of this format, etc. So that would be a serialized version of a table with 2 values in it. The unserialize method takes that and returns it back as a table with 2 values in it. So it's a nice easy way of transmitting effectively a binary object of a table using text only. So it gets that from the remainder of the message starting at position 13, and then 200 I've assumed as ample to more than exceed the length of the GPS coordinates that would be responded, added, returned. It then updates the turtle info with the info on that table. So the function that I showed earlier, taking that table and updating the relevant turtle's information. It then has a pause of 0.5 of a second. I've gone back to that. It seemed ample to still show the screen plenty enough. That was to try to avoid the lag I was getting in the world. And then it checks if the abort has been pressed, and if it's aborted, exits the loop and finishes. So that's it, and that's the A command, and it's now running on there. And because these are now running, I still got the abort lever down. There we go. So that's running on there. So as it reaches the timeout on each, so when that reaches 0, turtle 3 responded. So that's responded to 1 GPS request. And then in the next poll loop, turtle 2 got its message and it's responded. That one was still running, so it's actually done 28 since it was last reset. And then on the third loop round, this one will have finished. So what I can do is if I terminate that program and tell it to do go up 2 and then go forward 20 and then tell it to start up again. Oops. I like the fact that the turtle's gone way off out of range, but because I'm connected to the UI, I can still keep typing commands. So that's now turtle 1 should now get an updated location info the next time it polls through. I could probably do with saying which one the next turtle to poll will be. But what we should get, this is the third one through, so this is the worst case scenario, is we should see turtle 1's location info. There we go, gets updated. So turtle 1, which has now gone for a little wander over here, has now sent back its updated location info to there. And once you've got the GPS array set up right, which took a long time for me to find out and figure out how to do that, and many thanks to a wiki article I found, which I'll include a link to, it eventually made it all clear as to the best way to lay this out. I was trying to put as much distance between the GPS responding computers, so I had one down there and one over there and one up on the top and one over there, and I was getting really inaccurate results. And it was a combination of things. Firstly, I thought you only need 3 computers in the array rather than 4, and secondly, I was laying them out in an inefficient way for the triangulation code to work. And lastly, the difference in coordinates in Minecraft terms for the X, Y and Z and the GPS terms for X, Y and Z was also all confusing me. So many thanks to the wiki article that explained that, and the plan now is to build further intelligence into these so that I can send them off on a mission, and then they will do their best to be able to return back to a home location. Now, to do that, I found there is a bit of code out there that somebody's done with Pathfinder logic built into it, where the turtles can be set and told to effectively map out for their own internal map of a place and find which areas are free, which areas are paths to get from one location to another. So if that works as I think it does, then you'd be able to put these down in a mine and tell them to do some strip mining and then return home, and regardless of what gaps and holes they need to work through, they'll be able to find their way back, which will be great if it all works. That said, I don't expect to actually use these that much. It's mostly been an exercise in the fun of learning how to program. So that's it for now. I'll see you later.